All right, ladies and gentlemen, our final gas law problem for now. And what we have here is a problem where there's only one pressure. Oh no, there's two. There is a pressure here and a pressure here. They don't have matching units. So you're going to be using P1V1 over T1, except we're going to use this information right here. Volume remains unchanged means what you do on the test when you're told something remains unchanged. You've got P1V1 over T1 equals P2V2 over T2 right here. Cross off the one that doesn't change. It's not a variable. It means it disappears from the equation. Volume is gone because you were told it remains unchanged. What's another way to say remains unchanged? Volume is constant. Might be another way it is worded on the question. Okay. P1, P2. What is this over here? This is T1. And we want to know what the new temperature is based on just this information. T2. So let's look at set up and get T2 by itself. So what we have left over is P1 over T1 equals P2 over T2. And I want T2 by itself. Wow, a lot of work to be done here. T2 needs to be in the numerator. There's something that they might not have taught you, but they did teach you. You can do the same to each side of an equation, right? Can you just say this to yourself? Flip both sides of the equation to make my life easier when one of the things I want is in the bottom. Just flip both sides of the equation. It will still be true. T1 over P1 equals T2 over P2. You did the same thing to both sides of the equation, didn't you? This may seem like a miracle to you. You've never seen it before. You can do it anytime, any course where math is involved. Now I've got T2 by itself on the top. I'm going to multiply both sides by what now to get rid of P2 on the right? I'm going to multiply both sides by P2. So what's on the left is what we need, and what's on the right is what we need. So the right side is now just T2, and that's equal to P2 times T1 over P1. And in case you can't remember what we did, we flipped or inverted both sides. Do you remember why we did that? Because what we wanted was in a denominator. This is not the only way to do it, but this is a fast way to do it. Things we want need to be in a numerator. Okay? And so we got to use that equation. Now we can follow my steps. I'm going to convert the ATMs to millimeters mercury because I need the pressures to cancel, and they won't unless they have the same unit. See it right here? You can see it here, can't you? So ATMs is going to become millimeters mercury. And this would be given 760 mmHg. You've probably memorized it by now. In case you haven't, it will be on the front of your exam. So I'm going to take 1.121 ATM times something that gets rid of ATM and gives me millimeters mercury. There are 760 millimeters mercury in 1 ATM. So a little less than 900 is my guess. 1.121 times 760. 1.121 times 760. 851.96 millimeters mercury. And now we can do our conversion. Here's one. We got it right there. It's 851.96. Degrees Celsius to Kelvin, we got 5.192 Celsius plus 273 because given is Kelvin equals degrees Celsius plus 273. Given. And this one is 278.192. This is 278.92K equals T1. And that is P1. Use the correct gas equation. We've rejiggered our gas equation. It's right here. We found the correct one, and then we reformulated it to get T2 by itself. We're ready to plug and play. T2, 711 millimeters mercury times T1, which was 278.192 Kelvin. There's a 2 in there. All over P1, which is 851.96. Millimeters mercury. Canceling. Loving it. So 232. Oh, 2.1364. 164. And that would now be Kelvin, right? So we want it in degrees Celsius. We'll have to do one more conversion. One, are we surprised the number got lower? Yeah, the Kelvin went down. Not surprised. Pressure went up. Temperature goes down. Makes sense. Sorry, pressure went. It didn't make sense when I said it exactly backwards. It didn't make sense at all. Pressure went from 851 to a lower number 711. Pressure reduced, temperature reduced. And we want 3 sig figs, 232. And there you have it. And save. And everything you need is there. And we're done.